Today we are discussing about stack implementation using array. In previous sessions, we are covering the stack operations. If you without the knowledge of stack operation, we can't possible to implementation of the array. So first we learn stack all basic operation, then come to stack implementation of using array. So what are the possibilities of basic operations of stack? That all operations are same as possible to we are implementing the stack using array, but what is the difference? We are the insertion or deletion. What are the operations are available stack operations? That all things we are varying with, we are carrying with array format only. So what is that array? So array is a simple, it is stores the element contiguous. Array can store the elements contiguous. What is the meaning of contiguous? Means in that array the elements are stored side by side, near one by one it will be storing. So that is the difference of array and linked list. In linked list elements are storing not contiguous. So using array, so I am implementing the stack. What is the process? See this. Stack is a linear data structure that follows the last in first out principle. Last in first out principle. What is the definition and the principle? And it can be implemented by using an array by treating as the end of the array as the top of the stack. Actually, where we are inserting that element in that array, actually in that arrays we are inserting elements in end of the array. Similarly, that end we are assuming in that stack, that is the top, where we are assuming top. So a stack can be implemented using array where we maintain an integer array to store the elements. In that stack we are collecting from integer type of elements. That is the first point. And the second point, a variable capacity to represent the maximum size of the stack. So actually array can follow the fixed size of the size. So that's why we are representing the capacity is the maximum size of the stack. So that is the second point. And the third point, a variable top to trace the index of the top element. Initially top equal to -1 indicates an empty stack. In that indicates where we are stopping the order of values. Array can follow the index can start with 0, so that 0 is the actually initially top of the element. Initially without a stack, initially without elements in that stack, we have taken that initially top equal to -1, that indicates an empty stack. If you are having some elements at that time, in that stack can follow the indexes. See example of the diagram. This is the your array. Here some elements are stored. So some elements are stored, but index can start with array 0, 1, 2, 3. If you are having some elements at that time, index values assigning 0 to continue. If you having below nothing to elements in that stack at that time, top equal to -1. At that time that stack is empty. So that's why initialize to top equal to -1 and indicates empty stack. Then declare an array. Declare an array. What is that array? Stack. This is the size of the stack, max size. If you given the max at the time, it will be how much of you are given that size, that type of that much of elements will be entering to the stack only. More than that size of the elements, if you are pushing at the time, stack is overflowing. So initialize top equal to -1 is nothing but initially I am taking the my stack is empty. So that's why I am initialize the top equal to -1. Then perform operations using top. in that stack where we are insertion as well as deletion as performing at one end only. That end is called top. That's why perform operations using top position only. See one by one. What are the operations? What are the basic operations of stack? That operations same we are performing here also using arrays same. What are the basic operations? That all operations we are resolving by one. So what is the first operation? Using arrays. In first operation, pop operation. Sorry, first one is the push operation. In this operation, generally we are throwing or we are inserting to the elements into the our stack. So I represented to the array based stack. So this is my array based stack. So now element 1, now here push as well as here only pop. So this is actually we are performing push. Now I am draw only push operation. So now 10, 20, 30, 40. How many elements are inserted? 40 elements are I am inserting. So this manners only. But first will be inserted 10. So that will be 0th position stored. Second element will be pushing after successfully completion. That will be assign the index 1. Next element 2. These 3. These are the indexes. Index values. So okay na? This is simply push operation in our stack using arrays because of we are following that array. Array is nothing but it can store the values contiguously. Contiguous is nothing but side by side. That means linearly. So okay, so this is the push operation. So at that time, performing the push operation, first your stack is space is available or not. So check that condition. So that's why I'm putting here check check if top equal to max minus 1, top equal to max minus 1, then what happened? Stack is overflow. Stack is overflow. Else, and what happened? Else, stack is not overflow. At that time, push operation successfully completed. So that's why I'm writing here the pushed element is percentage d and value the pushed element is percentage d and that what is the value, then automatically what happen, if your top equal to max minus 1, stack is overflow. At that time nothing to operation successfully completion. So otherwise another way, if top is equal to max minus 1 already full, else in case stack does not full, at that time you are pushing element into our stack, it is accepted. So at that time what happened, here it will be place is there. So at that time we are pushing to the element 5, that will be successfully completed. Then here before we are pushing to the element, this is the top. After successfully we push into our stack, it will be updated to the top element. So that is top equal to top plus 1. So here we are writing here, then top equal to top plus 1. So that is the simple push operation in our stack using arrays. So next, second operation. What is that second operation? pop. Second one operation pop. Here in this operation we are performing removing the element from the stack, removing from the stack. So before we are removing the element, first we check the condition. What condition? Stack is empty or not. If stack is empty, at the time what happened? We are not popping operation successfully. If you having some elements, at that time we are performing push operation. So next I write the query here. Here our stack is now. So this is our stack. Now I am pushing operation, sorry, pop operation. So at that time this is empty stack. So at that time is possible to popping? Is possible to removing from that stack? No, because of stack is empty. Now stack is empty. So now your top equal to -1. Top is here. This is the top. Here we are defining here top equal to -1. At the time we are not removing from that stack. So we are writing that query. What is that query? If top equal to -1, then what happened? Stack is empty. Stack is empty. Otherwise else. If stack is not empty, at that time in that stack having some elements 10, 20, 30, 40. Now this is the top element. This is the top element. If you stack having some elements, at that time successfully performing pop operations. So that's why we are writing here the popped element is percentage D. Which element popped? In that stack, top of the element. So that's why we are writing here stack top. In that stack, which element is available top position, that will be popped from the stack. So that's why writing here after successfully completion of pop operation. So at the time see, observe your figure on the diagram, it will be pop. 40 will be pop. Then top position will be, what happened? Top will be decreasing. So this is the top. Now after completion of pop operation, your pop will be top -1. So then we are commented here top equal to top -1. This is the simple pop operation implementation of stack using array. So next, what is the next operation? Peak operation. So peak operation. Third one, peak. In this operation, we are finding the top of the element in our stack using array method or array pattern. So here also same, if you find the peak or top of the element of our stack, so first you check the condition. What is that condition? If stack having some elements, at the time is possible to find the peak element, otherwise not possible because of stack is empty. At the time how to find that element? So representing the diagram. So this is push, this is pop. How many? 4 elements are there? 10, 20, 30, 40. Stack. This is stack. Okay. So here observe peak. So before see, before it that at this time the observe this diagram, to find the possibilation of peak element? No, because of stack is empty. So that's why we are writing if stack, that means top equal to minus 1. If top equal to minus 1, then what happen? Not possible. And because of the stack is empty, so that's why here reflecting stack is empty. Stack is empty. Otherwise is nothing but else part will be executed. If stack having some element, that means if stack does not equal to minus 1, so at that time stack having some elements, at that time to find the top of the element in our stack, find the top of the stack. So what is that query? Here stack top equal to value. In that, observe this diagram. Stack is empty, so at the time there is no elements are stored in our stack, that is empty stack. Otherwise else part will be executed. At that time stack having some elements. Now 10, 20, 30, 40, this is the top element or peak element. This is the top element or peak element. So that's why here we are representing here to find the top of the stack, and you see stack of top equal to value. This is the simple procedure of peak operation, implementation of stack using array. So next operation we are performing. What is that next operation? Is full. So is full. In this operation, to check the stack is full or not at the time of implementation of stack using array, first of all check the condition. What the condition? If the top equal to max minus 1, so at that time, see, observe your diagram. So this is your stack 1, 2, 3, 4, 10, 20, 30, 40. This is top position. This is a stack. This is the top. So now this size is max. So max present top position is there in our stack. Top equal to max. At that time your stack is fully loaded. If you insert another value already full stack, at that time what happened? Top equal to max minus 1. Sorry, top equal to max minus 1. So at that time stack is overflowing. So at that time stack is full. So we are writing here if top equal to, so now here draw this diagram. 10, 20, 30, 40. This is top. This is a max. So now we are trying to an element. So at the time top equal to max minus 1. What happened? Here simply displaying stack is full. At the time it returns true. It returns true means stack is full. Otherwise else part will be executed. False. What is that here? Else stack is not a full. This is simple description about our stack is full or not, check the condition at the time of implementation of stack using array. So now what is that next last? Stack is empty or not. So that's why we are writing is empty. Is empty operation is used to check the stack is empty or not. So at that time, first of all, we write that query. What is that? If top equal to -1, then what happened? If top equal to -1, it returns stack is empty. Stack is empty. Otherwise, it will be else what will be approach stack is not empty. Stack is not empty. This is the simple logic about stack empty or not. Check the conditions. Okay. If the stack is empty, it is true. At the time stack is full, is false. At the time stack is not full. Sorry, stack is not empty. So this is the simple diagrammatically representing stack is empty. This is empty stack because of your top position here. Top equal to -1. So at that time, empty stack. Empty stack. This is the simple theoretically I am explaining the stack implementation using arrays. So now I am explaining continuous programmatically, then step by step what happened. See, observe how to write a program implementation of stack using array. Array start include stdio.h, then define max 5. Because of where stack size is universally constant value, that means next stack is implementing, then we are taken that stack int stack max stack. So I am defining the what is the stack name, stack max. So now in that stack I am importing to the integer type of value, so that's why I am taken int stack of max. Max is how many elements are inserted maximum? 5 elements are inserted into the our stack maximum. So now int top equal to -1, then what happened? We are taken an empty stack. Because of this statement, top equal to -1 means stack is empty stack. So next from starting to the, so now output based we are observing here creates it. This is empty stack. So next I creating a functions. First one, void push int value. Here if top equal to -1, top equal to max minus printf stack is overflow. Here if top equal to max -1, at that time stack is already maximum values are stored. Whatever may be inserted at the time of max values are stored in the stack. At that time that value will be overflowing automatically. So that's why we are writing that query. If top equal to max minus 1, then stack is overflowing. Else, else if stack having some space at that time is possible to enter the element. So that's why top plus plus, what happened here, top plus plus nothing but successfully inserted element. So printf percentage d is pushed into stack, then value. So which value we enter successfully in our stack, that element, that value will be reflecting to top plus plus. So now this is a push operation. This entire block will be getting push operation up to where he, this is push operation. Now start with uh, pop. Now I am creating pop operation. Creating pop operation. Wide pop operation. So at the time, pop is nothing but we are removing element from that stack. So that's why we are writing here, if top equal to -1, at the time what happened, if top equal to -1 means stack is empty. At the time is possible to pop operation? No, not possible. When it is a possible, if stack has some elements, at the time it is possible only. So now printf stack is empty. Stack is empty. Else part will be executed. Continuation writing here. Else, just what happened? Else having some element. Else means nothing but in that stack having some elements. Then printf percentage d is popped from stack. In that, which element is popped from your stack? In that stack top element. In that stack top element. Now automatically successfully performing the pop operation in your stack, then top element will be updated. Then what happened? Top will be decremented. So top equal to top -1, then stack top equal to value or element. This is from pop operation. Next I am finding to the peak operation. I am writing the query of peak operation. So now void peak. Now I am starting here peak operation. So at that time we are saying, we are finding the top of the element in our stack. At that time you check the first stack is available or not, in that stack having some elements available or not. So that's why I am writing, if top equal to -1, then what happened? Here stack is empty. Printf stack is empty. So at that time not possible to finding the top or peak element. So else what will be executed. So if top equal to -1 at the time is not possible, else otherwise it is possible. Else what will be executed. What happen else what to find the percentage D is top element. Percentage D is the top element. Where is that element is top? Our stack. So here stack top. So then it will be completion about peak operation of in our stack implementation using array method. So next I am writing display method. Okay, display method. So I'm writing here. Next void display. Void display method. Here also same, if you display the elements in our stack at the time, check first condition, stack is empty or not. If your stack is empty, at the time you possible to the display what are the elements available in our stack? No, because of stack already empty, at that time how can it is possible to display the elements? When it is possible, if having some elements on the stack at that time is possible to the display. So that's why I'm writing here, if top equal to -1, here printf stack is empty. Stack is empty. Else what will be executed if stack having 0 elements at that time stack is empty, otherwise else what will be executed. What is that else what? If stack having some elements, so now this continuation, what happen else printf stack elements one by one print. So at that if having some elements at that time it will be one by one display. So it is observe your stack 10 20 30 40. So 4 elements are, so I am one by one displaying our stack. So first element will be displaying in results based output. Which element is available in our stack, that element will be displaying that. So now I am taken for loop int I equal to top I less greater than 0 I decrement. See this display function, we are initializing I equal to top. Now this will be top. First that element will be display. After that second element, after completion of that I value will be changed. So index values 0 1 2, this is 3. So comparing to the every time we are taken that I equal to top is 40. That 40 is comparing to that index value 3. 3 is more than 0 or greater than 0. So it is satisfy the condition, then display the output. After completion of first iteration, then it will be decreasing, not increasing. Decrease means below values, increase means above values. Now here decreasing, so 3 already successfully completed, then it will be in decrease, I value will taken 2, that 2 is greater than 0, so it is satisfy condition, then it will be 2th position, second position of your stack, what element will be available, that element will be printing. After completion of second iteration, I will be decrease means it will be going to the I value 1 is greater than 0, so okay, condition is satisfied, that value will be decrease. So another iteration decrease, if you have taken that I value 0, so at that time, so okay, sometimes we are I is greater than or equal to 0, at the time it will be 1 by 1 display. So now printf is d slash n stack of 5. That means here condition following here. So all operations successfully completed. Wide push, pop, one stack elements. So that is the 4 operations of the stack implementation using arrays. Now I am writing the main. So push 10, push 20, push 30, then peak and pop, then display. Again pop. See out. So what is expected out? Guess and what is that expected output, and continue that output. So this is the simple implementation of stack using arrays. So thank you everybody.